Hello everyone, welcome to EkEdu. This is Rupal Vats and I'll be teaching you physics. So let's start from wave optics. So under wave optics, we'll study different topics: Huygens principle, interference, diffraction and polarization. These all will be helping to explain you the wave nature of light. Okay. So let's start from interference of light. What is basically interference? Interference is basically the superposition of waves. Superposition of waves in such a way that the intensity, or we can say the amplitude of the resulting wave that you are getting, that is completely different from the intensity or amplitude of the individual waves. Okay, so let's read it. And what does it lead to? See, it is a phenomena of redistribution of light wave on account of superposition of monochromatic light waves. Okay, monochromatic means single color, and we are dealing here with coherent sources. Coherent sources, we have studied that coherent sources are those which have same frequency, two sources which have same frequency, and the phase between them, either the phase is same or a constant phase is maintained always. So the superposition of such light waves, as a result of which a pattern of alternate bright and dark fringes is obtained on the screen. You know that in interference we are getting either constructive interference or destructive interference. Constructive, when two troughs or two crests coincide, okay, they superimpose, then what we get? Maximum intensity. Maximum intensity leads to bright fringe in this case. Okay, and dark bands, the opposite one. What is the opposite one? The destructive interference. Destructive interference means when crest of one, see, so bright bands we said when two troughs or two crests coincide, and if the opposite, if crest of one coincide with trough, it is like this. Okay, then we say we are getting destructive interference or we are getting the dark band. See, in this figure, this is the figure to explain interference. Actually, we deal with Young's double slit experiment. That is the basic experiment to explain, to understand the interference of light. So see, what is there? Here is some source of light, and here there are two sources, we can say, two coherent sources. See, instead of using two different sources, we have taken here two slits only. Why? Because if suppose you have taken two bulbs, you are saying that ma'am, they are of same frequency, whatever the ratings are there, that are same, but always there are some manufacturing default and something that you won't get the same frequency, the same phase. Thereby, to get rid of that problem, we always use a single source, and then we are taking these two slits. Now, as per Huygens principle, this will produce secondary wavelets. These would themselves act as two different sources, okay, two coherent sources. Okay, so this is how interference is taking place, and on the screen, see, on the screen you are getting interference pattern. What is interference pattern? Alternative bright and dark fringes you will be getting. Okay. Interference is the superposition of two coherent waves, coherent sources I have already explained you. Then is, this is all what we will be studying in interference. We will be studying about the expression of path difference in Young's double slit experiment. Next is condition of constructive and destructive interference, that I have already told you what is constructive and what is destructive interference. Then is ratio of maximum and minimum intensity, and position of bright and dark fringes. On the screen, I have said we obtain alternate bright and dark fringe. This is bright fringe, this is dark fringe, complete darkness, and here you are getting a bright spot. Okay, so what is the location of this? What is the position of these? That we also will studying. And next is the fringe width. What is fringe width? The distance between two maxima or two minima. This is denoted by beta. Okay, this is fringe width. So these all topics will be covered in today class. So this is the basic diagram, this is the basic experiment conducted by the Young's double slit experiment. See, a single source of light you have, and here these are two slits, S1 and S2. The distance between them is small d. For interference to occur, the condition is that this d must be very small, and this d, this large distance d, this capital D, it is denoted by capital D, it must be very large. This is the distance between the slits and the screen. Okay, so this is our experimental setup, how it is placed. The distance between the two slits is small d. The distance between the slits and the screen is capital D. This is the position of our fringe. Here we denoted by dark fringes or bright fringes. Okay, so this is the position denoted by X. And how do we calculate the path difference? See now, what will happen? Wave goes from there, and let's say we have taken any arbitrary point P. Okay, it covers this much path, let's say R1 we call it, and the wave going from S2, okay, it has covered this R2 path. Okay, so obviously you can see that R2 is greater than R1 because the P point is towards this side. So let's drop, we calculate, we find the path difference denoted as S2P minus S1P. What we are saying, the difference between this path of light and difference between the path covered in this from S1P. Okay, so what we have done, we have dropped a perpendicular, this S1A, this perpendicular we have dropped, and we are saying, because we have taken this length to be very small, we are saying let's say this angle to be theta. This angle you can see it as theta. So this will also be theta. How come it is theta now? See, let's say this angle we are calling as alpha and this angle we are calling as beta. Right now we are not saying that this angle is theta. We are saying that this angle is beta. So what is the condition? Alpha plus beta is equal to 90 degree. Also this we are saying we have dropped a perpendicular from S1. Okay, so we can say this which we have earlier taken theta, theta plus alpha is also 90. So from here we can conclude that beta is equal to theta. It means that this angle is also theta and this angle is also theta. Okay, now switching back to how to calculate path difference. Path difference we have said is equal to S2P minus S1P. We have dropped this perpendicular and we are saying path difference S2P minus S1P. We are approximating it to this value S2A. Okay, so it is S2A. And how we will calculate it? See, this is a right angle triangle. Okay, so we can say that sine of theta in this triangle, take this triangle and you can see that sine of theta is perpendicular upon hypotenuse. So it is equal to the path difference that we are saying S2A upon the hypotenuse is small d. Okay, so we have observed that sine theta is equal to S2A upon d. Now consider another triangle. See, right now we have taken this triangle. Now we are considering this particular triangle. And we can say that tan theta is equal to what value? It is equal to x upon capital D. We have these two values. Okay, we know that for very small theta, for very small angle, sine theta can be approximated as tan theta. So we can equate both of them and we can get x by d is equal to S2A by d, where S2A is the path difference, and we can say that path difference is equal to xd by d. Okay, this is your formula of path difference. Now you know that there are different conditions for constructive as well as destructive interference. So for bright fringe, that we are saying as constructive interference, we can say there will be a condition on path difference. What will be that condition? For bright fringe, or we can say for constructive interference, the condition on path difference is that it should be n times lambda, integral multiple of the wavelength. So just equate this value xd by d and you are getting, this is what? This is the position of our fringe. In this case, it will be the position of bright fringe. In other case, it will be the position of dark fringe. Okay, so X is obtained as n lambda capital D upon D. Similarly, if we are taking for dark fringe, the condition is that path difference should be equal to this value, 2n minus 1 lambda by 2. Okay, so just equate this. So these are the particular condition, and we can say that in this case the position of our minima, because dark fringe, so we are saying in this case we are getting maxima. Maxima means maximum intensity, and here we obtain minima, that is minimum intensity. Okay, so here X is obtained like 2n minus 1 lambda by 2 D by D. Okay, so these are the position of our bright fringe and dark fringe. Now, as we have said earlier, we will be calculating the fringe width. This distance between two minima or the distance between two maxima, that is known as fringe width. Okay, the distance between the maxima, two bright fringes or two dark fringes is known as fringe width. Okay, in this case, here we are obtaining some mth fringe, and at some distance above it, here we are obtaining m plus 1th. Let's say this is nth bright fringe, and this is n plus 1th bright fringe. Okay, so the distance between these two will be the fringe width. So how to calculate it? See, how do we calculate it? We have seen the position of maxima is equal to n lambda D by D. Okay, and for this is the position for nth maxima. For n plus 1th maxima, we can say this is n plus 1 times lambda D by D. So what will be the fringe width? Fringe width will be the distance between x n plus 1 minus xn, the position of n plus 1th bright fringe minus the position of nth bright fringe. Okay, so this is equal to, just subtract these values, you get this is minus n and lambda D by D. So this cancels out and you are getting lambda D by D. It is the value of fringe width in case of bright fringes. Now you will observe, even for this value, if you take for dark fringes, what would be the fringe width? Is it same or it will be different? See, xn is again 2n minus 1, this is lambda D upon 2D, and xn plus 1, this is n plus 1, so this will be equal to 2n plus 1 minus 1 lambda D by D. Okay, so when you observe this difference, xn minus 1 minus xn, this is equal to 2n plus 2, and see here it is minus 2n plus 1 lambda D upon 2D. So this will cancel out, and here I have left something, this is 2n plus 2 minus 1, 1 minus 1 I have left. So this will be 2 times lambda D upon 2D. So see, again you are obtaining the same value, lambda D by D. So the fringe width, the value of fringe width remains same whether you find the distance between two bright fringe or you obtain between two dark fringes. This distance and this distance is the same for all. Okay, so this was all our topic for today. Thank you.